Okay, so we're going to have a look at a question here from the 2022 HSC Advanced Maths paper. This is question 32, part A. This is one of the hardest questions in the paper. In this paper specifically, probably question 31 is a little bit more complicated, but this question is still reasonably challenging. So we're told in a reducing balance loan, the amount P is borrowed for a period of n months at an interest rate of 0.25% per month, compounded monthly. At the end of each month, a repayment of M is made. After the nth repayment has been made, the amount owing AN is given by the listed formula. We're told Jane borrows 200,000, so we're told that P is 200,000 in a reducing balance loan as described, so we're told that the associated formula is applicable to this question. We're then told the loan is to be repaid in 180 monthly repayments. That means N is going to be 180 because N is the number of months. We have to show that M is equal to 1381.16 when rounded to the nearest cent. So we're going to be using this formula to do this. Now, this has a long sum in it, and we first need to condense that sum. So we have a geometric series here, in fact. 1 plus 1.0025 to the 1 plus all the way up to 1.0025 to the n minus 1. This needs to be written in the sum of a geometric series form. So the first term in this series is 1. The multiplication factor between terms is 1.0025. The number of terms, we're going from 1 and then 1.00 to the 25 up to 1.0025 to the n minus 1. That means there are n minus 1 plus 1 many terms. N minus 1 plus 1 is just n. So there are actually n many terms in this particular geometric series. So this means the sum of terms in this geometric series is 1 times 1.0025 to the n minus 1 divided by 1.0025 minus 1, which is 0.0025. So this is 1.0025 to the n minus 1 over 0.0025. We're going to sub this in to our AN formula. So this gives us AN is equal to P times 1.0025 to the n minus M times 1.0025 to the n minus 1 over 0.0025. Now we need to use the information we have about the question and this condensed form of the equation in order to show that in the case where 200,000 is borrowed and is repaid in 180 monthly repayments, the monthly repayment is 1,381.16. So we're going to let P equal 200,000, N equal 180, and we're going to let A of N, so AN, equal 0, because we need the amount owing at the end of this loan to be 0 in order for this to be the correct repayment. So this gives us 0 is equal to 200,000, just plug these all in before I rearrange this, times 1.0025 to the power of 180 minus M times 1.0025 to the power of 180 minus 1 divided by 0.0025. I need to rearrange this so that it is in the form of M equals. So I can add the M term to both sides. I therefore get M times 1.0025 to the power of 180 minus 1 over 0.0025 is equal to 200,000 times 1.0025 to the 180. Divide both sides by the term multiplied by the M. This gives me M is equal to 200,000 times 1.0025 to the power of 180 divided by 1.0025 to the 180 minus 1, all divided by 0.0025. Now I just need to put this in the calculator. When you're putting this into your calculator, be very careful. This is a very large sum to be putting in to a calculator in a single process, and so it's very easy to mess this up. So 200,000 times 1.0025 to the power of 180 divided by, and I'll put when I'm doing this in my calculator, I'm actually putting the denominator component in brackets because we really want that to happen. We want the calculator to take the input exactly as it's being shown here. So we have 1.0025 to the power of 180 minus 1 divided by 0.0025. You'll know if you've done it right if you get the correct answer because of the way the question's rounded, but it's good to be as careful as is possible. So the calculator tells me that this is 1381.16328 ... So therefore m is equal to 1381.16 when rounded to 2 decimal places. And this is the answer to this particular question. So this is the answer we're after. Now this is worth 2 marks. 1 mark will be for working that gets you towards a correct answer. The second mark will be for having the last stage of the question, which is finding this answer. So in terms of the working we have here, the first mark will be awarded for most of the working I've done in this question. Using the series formula, subbing that in, plugging the values in, rearranging and solving. The second question will then be forgetting that m is 1381.16, using the fact that the loan was 200,000 and the loan had to be repaid in 180 monthly repayments.